All right, hello, and welcome to IoT Live Demo Panel 2. And we have a great couple sessions lined up. We have 4 speakers and should go for about an hour. So starting us off is Terlompos, and he'll be talking about Compose project. So I'll hand it over to him.
Good, thanks, Trevor. So good afternoon, everybody. Good evening, and happy Internet of Things Day. Here today to talk to you about Compose project. Let me share my screen right away. So let me know if you can see the first slide. Ready?
Yep, it's looking good.
Okay, great, thanks. So I'm gonna briefly present Compose project, which is about building an Internet of Things marketplace for makers and entrepreneurs to build and host their applications. And the main motivation behind the project was the fact that, when you want to build and deploy IoT services and applications, it takes a lot of effort. Firstly, you have to know about backends and cloud infrastructures and be able to manage them, and also do a lot of things about data and user maintenance. When it also comes to devices, there is a huge diversity of different devices and protocols for communication, so you have to deal with that as well. If you want to integrate external APIs, you have to find ways to study them, to learn about them, and integrate them into your application. And finally, you have to build and deliver your mobile or web applications. So even if you are a maker and you do this as a hobby project, or if you're an entrepreneur and trying to build a business around it, it takes a lot of time to identify the right software and hardware to use, or the libraries and the right APIs to integrate in your project. And then, of course, you need to also take care about adding data and finding users. And all this, apart from time, translates into money. And you need resources to do hosting and scalable hosting, to do data management and infrastructure management. And in many cases, you need to outsource parts of these tasks, which, again, translates into a lot of money. So we had an idea of providing Okay, I had some noise. So, the European Union provided some funds to build this project, and you can see the partners on here. We got some research centers, universities, and small or big companies that are involved. And what we are actually building is a scalable platform as a service. It's a cloud service that can be used as a marketplace to host build applications and provide them to users. So this cloud environment comes with development tools for hosting, for building applications, as well as with supporting sessional communication technologies, so that you can actually build Internet of Things applications and services. And the cool part about Compose is that it's completely free, and it's pretty much open source, apart from very specific components that even if we remove the whole idea, the whole project, the whole platform can operate, and will be totally open source. So you will be able to download it and host it in your own cloud environment or a single machine. I won't go into many details because I would like to move on to the demo shortly. Just to give you an idea of the overall architecture, we have conceptually 3 different layers. We have the lower part, which deals with communicating with smart objects and devices. The middle layer, which is the runtime engine, where all the services and applications are running. And then we have the layer that deals with communication with users, either application end users or the developers themselves that build and deploy applications. Compose is based on Cloud Foundry, so another open source project. And what we're doing is that we're taking all the nice and cool things about Cloud Foundry, and we are enhancing them with additional software components, mainly open source, and so that they are more Internet of Things related. So we provide things like a Couchbase database and Storm for real data stream processing. We provide nice SDKs and visual tools for people to build applications. and additional things. We're trying to be very developer friendly. We're going to provide an Eclipse plugin and a command line interface so you can directly push your Java code to the platform. And if you're even less familiar with programming, we are integrating Node-RED. I'm not sure how many of you are familiar with Node-RED. It's a Node.js-based workflow editor for the Internet of Things that gives you the ability to simply connect different nodes to each other and build applications that connect to different services. Yes?
Sorry to interrupt you. It looks like we might be losing your slides, so would you mind going to the non-full screen mode for us?
Yeah, sure.
Thanks,
do you
sorry.
want me to go back or?
Just maybe go back one.
Okay, so.
And I think you can enlarge it a little bit, so without going.
Okay, so couple slides back now, I was mentioning that we are based on Cloud Foundry, which is also open source, and we are actually enhancing Cloud Foundry so that it can be used in the IoT domain. So we are adding things like sensor data stream processing, Couchbase database, and interfaces for easily writing and deploying applications. Speaking of which, we're building a plugin for Eclipse, so you can easily deploy your code while you're editing it. And even if you're not very familiar with coding, you can use, we're integrating Node-RED, which is a graphical workflow editor for the Internet of Things. It's a really nice visual interface where you can simply connect nodes together, like building a pipeline. And these nodes are related to IoT devices, so you can connect your Arduino or your embedded platform and read data out of it and send it to another service or consume data from another service. Build a workflow and deploy it and run it on the Compose cloud platform so that it can easily scale and serve your purposes. We sort of try to take security seriously, so every component is covered in terms of access control and secure communication, and also we provide full identity and user management and data provenance. So every single data transaction inside and outside the platform is logged and can be used for security purposes as well. We provide also service discovery, so we have partners that deal with semantic annotation of services. So when you want to build your own application, you can easily make queries and see what other developers have built, and you can reuse their services or components if they provide them for free. So a few more slides and then I conclude. How to use Compose. Let's say that you're a developer and you have an idea about an Internet of Things service. So you want to connect a smart or a not so smart device to the internet. What you do is you will use the SDK of Compose or the libraries that will come for this connected device and will allow you to easily communicate with Compose backend, the cloud platform. You can use the tools to discover external services that can provide you, for example, information about if the weather is good outside and you should go out jogging or you should stay inside and watch TV. And then you can simply write your own application and deploy it, manage and publish it in the marketplace. Simple as that. What's the current status? We have one big part of the platform. It's called Serviodyssey, and it's accessible and usable, and you can access it right now. It's an open source component of the cloud that can store sensor data, and it really simplifies the way you can do IoT streaming. We are preparing a Cloud Foundry installation that is IoT enabled, so it's going to be a Cloud Foundry image that you will be able to download, install, and have a Compose platform on your computer. We currently support REST protocol for communication with external services in your applications, as well as MQTT for communication with embedded devices. And next steps are to provide additional communication protocols like XMPP, WebSockets, etc. Fully integrate Node-RED as a visual editor for building applications, add semantic support, and finally provide as many libraries as we can for embedded devices. And this is the part that we would like to receive some help from the community. And so if any developer would like to participate and assist in building SDKs and libraries for devices like the Arduino, Raspberry Pi, or the Tesla, or any new hardware platform that is out there, they're very welcome. These are some links. You can find more information about the project. We have a Twitter account. We have, for now, two different separate GitHub projects where you can find all the source code that is developed and published. We have a Facebook page. And please stay tuned because we're doing many workshops and hackathons. Unfortunately, they're going to be held in Europe. But we're also going to have online competitions with prizes for developers that will use Compose to build their own applications. So with that, and if there are not any questions at the moment, I would like to show you a very small demo about Compose. So this is the Servioticy platform. You can go to servioticy.com. There is a full documentation and description of the API and how to use it to collect sensor data and store it on the Compose platform. And there is a very simple online demo. Servioticy is built by our Spanish partners in Barcelona. So they have a network of sensors that collect information like the temperature. So you can click on a location and get the information about the location, coordinates, and the current temperature. And the cool thing is that it supports many sort of data processing and querying, like geolocation querying. So if I click on the map, it will really fast show me the sensors that are in a 300-kilometer radius. And then we also provide additional stream data processing, like I can produce a heat map really fast, and I can have a visualization of the sensor information as an additional layer of information there. You can play a bit with the demo, and you can also always visit the page, the web page, and find how you can install your own instance of this Compose component and how to use it. And then another small demo I'd like to do is with using Node-RED. So I have an installation of Node-RED on my machine, and what I'm doing here is I'm sort of reading all the public Twitter feeds that contain the IoT hashtag, and I'm using Compose to sort of push them inside Servioticy and store them. So if someone soon will probably post something about the Internet of Things using the hashtag, I'll start getting the information. This is the output from the Node-RED. So this is what I'm sending to Compose backend. And then there is a simple REST API to read the data. So I have a REST client here, and I can query all the tweets that I've collected the last few days. Actually, I started like a couple of hours doing that, so I can receive all the tweets that are stored. I'm storing the location of the tweet, the tweet text, and the user, and I can always get the latest data value also. Oops. No, I'm currently not having the last update. Yeah, so there are a few functions that are already provided instead of manually querying the data that is stored, so you can get the latest sensor readings, let's say. And using this very simple API, you can generate platforms that already exist out there, like ThinkSpeak, Zybly, or whatever else. But this is totally open source and totally free, and you can download it and install it yourself. Going back to you, Trevor.
Thank you. It's really interesting. It's fun to see some of these projects starting to get integrated together. If you can stick around, maybe we can have some follow-up questions after the rest of the panel. But up next we have Aaron from Zebra Technologies and Grant Miller from our one of our earlier sessions showed a little bit of a preview of Zatar, and she's going to give us a little demo of what that looks like. All right.
Yes. So let me share my screen. One second. Can you see my screen?
Yep, it looks good. So.
Okay, hold on. So here we are on Zatar.com. So right now I'm going to take you through Zatar and the web app. So Zatar is Zebra's IoT platform for enterprise-grade applications. It's a cloud-based way to connect and control all your devices. Plus, with our API, it's extendable, so you can customize your app to fit any business need you may have. So to start off, we'll log in. Up here. And I'm going to show you my login and my account. As you can see, if I get the password wrong, it will tell you. So here's my private world. That's immediately what it will show you on Zatar when you log into the web app. And from here, it'll also show you your devices. So these are all the devices that I have in my private world. It'll also show you groups. So for example, I have an office group, which I have an iPad in, and one that I call Aaron's printer. And we'll also have a warehouse, which I have an edge box in, or my edge box. You can also create device profiles. Currently, profiles, since we are in beta, currently we are working on the feature. So right now you can add a device profile, but adding it to a particular device is not yet available. But you can also invite members, and you can invite members to join your world so that they would be able to see your devices. So right now I'm going to add a device to my world. So one of the ways is it can search for devices, or you can add it manually. And since I know the ID for this particular device, I'm going to add it manually. Also, you can download an app. If you want to add an iPhone, you can download the app from the App Store. So let's go ahead and add the device manually. Device type, I'm going to add a printer. The model. And I know the serial number. When you're adding the serial number, it is case sensitive. And this is optional, which I do not need an edge box, so I'll just say next. I'm going to name it. So here I'm going to name it CM. And location is Chicago. So right here, you can see, here it is. It shows up in my public world, or my private world. Now, to get these device settings to show up, I want to go into the settings and say printer settings as of today, refresh. Consequently, here is also where you can get printer settings, the settings for the printer for darkness, print speed, print mode, and then also media type, label height, additional settings. So it'll take a second, but these will show up pretty soon here. In the meantime, we can add this device to a particular one. So here, if I wanted to add that device to this group, go here, and then I would say and then this device also shows up within Office as well as within here. Additionally, you can also invite members. Like I could invite myself for my other one. There we go. And then I will receive an email in that particular email inbox to invite. I click on accept invite, and that person will be able to see this world. For example, these are the worlds that I have access to. So one of them, another one is printer demo, and these are the devices within that world. And I can see from there, for example, this one, this status, this status features have already been, the attributes have already been shown and updated, and so you can see the status as clear, battery, IP address, location, firmware, various different info regarding to that particular device. So this is a world that I've been invited to, but by default, we also have access to a public world. And the public world differs from the private world, as this one is everybody who has been every member of Zatar who has enabled their device to be shown publicly will show up here. And just because you show a particular device in the public world doesn't mean you have to show particularly every aspect of the device. For example, an Apple iPhone. This one shows various different attributes that pertain to that particular phone. And this particular user has chosen to make all of these readings public, available in the public world. Whereas this one has chosen to not make all those particular ones public. And for example, this one is a group that we all have access to, but yet nobody has yet shared their devices with this world. Even though we've all been invited and we all have access to it, nobody's in there yet. So you can choose to use your world and make access to your world for different people in different ways. Now from here you can also do settings, and you can do account settings. So this one will show my name, company, location, username, email, and then here also the ability to reset your password. Here too, you will also be able to report a problem, which will take you to the Contact Zatar page on our website. It will also take you to the Zatar community, and here is where you can get various information about the product, about Zatar. So here's where you have our API documentation. So as you decide to maybe develop an app to extend the capabilities here further, you can do so with the API documentation, and feel free to peruse it. You can also do facts. These are just frequently asked questions. And again, Ask Zatar will take you again to the contact page. We also have a forum where you can join the community and ask questions about particular items. And here's a particularly important part. You have, this is our supported devices page. So these are all the devices that are currently supported by Zatar. And we are adding devices all the time. So as it says here, check back soon for updates if you don't see the one that you have there. So also, here's where you'll find, if you want additional information, we also do a blog, and regularly we do a Feature Friday, which is usually a feature about Zatar or of Zatar. And if you want to extend the feature and learn more about, for example, the app, the iPhone app, here's a good place where you can go and actually demo the features of Zatar. So I encourage everybody to go and review it and look at it and give feedback. As we said, we are currently in beta, so any feedback is very helpful, and as we go further, constantly new features will be updated and things will come up as we have new releases. So I think this gives a good overall view of what we currently have in Zatar, and that's what I have.
Thanks, Aaron. I actually got dropped out for that last few seconds. So I did have a couple quick questions for you on with those public pages. Can you subscribe to some type of feed to access those, or
for the website, like the blog, for example? You're talking about the blog, for example?
No, I was talking about the. I know that the platform you can do public, shared, and fully public, or private, shared, fully public. On the fully publics, is there? Can you access some of their sensor readings or any of those elements?
You can access readings of those particular devices, but being able to, you're talking about maybe have a feed to say that you get a notification if something changes. Currently we don't have that implemented, but it is a good idea that maybe we can think about down the road.
And with the public beta you guys are having, is there a device limit, or can people just kind of explore it at this point?
Well, people can kind of explore it at this point, but right now we do have a limit of 5 devices. And then if you want to go above and beyond that, I would contact us, and we can definitely, depending on the situation, definitely accommodate.
Okay. Well, great.
Because this is scalable from 1 device to 1,000 devices, so and more and beyond that. So
yeah, I watched some of Grant's talk, and it sounds like you can go all the way up to enterprise.
Yeah, exactly.
Stuff, so.
Yeah. So, and with the API as well, you can. There's many different devices, and as devices come up, ones that we haven't even thought of yet, there'll be new needs for new features and possibly different ways of looking at things. So it's definitely a thing that's constantly evolving, and so feedback right now is very valuable. So anything you guys have would be great.
Okay. Yeah, we'll make sure to put some links in the.
Yeah, exactly. Well, social media, we do a lot with Twitter and stuff like that too. So.
All right, great. Well, it looks like we might have lost Joachim somehow from Stockholm. He was supposed to be next on XMPP, and he was here, so he'll probably show up in a few minutes. But Adam, are you available to do your talk? Let's see if we lost him. All right, great.
Trevor, Trevor, this is Benjamin. Not sure if you've seen there is a question on the Q&A.
Ah, thank you.
Welcome.
Okay. Let's see. Yeah, so Aaron, if you're still on, we just have a quick question from the audience on what type of devices Zatar supports at the moment.
Oh, that's a very good question. So right now we support multiple types of devices, and to get more information, like we showed before, you can go to the device. Let me see. So we have an iPhone app. We do support iPhone. We also support Raspberry Pi, sensor tags, Intel, RFID readers will be coming soon, and those are coming very soon. We're working on that right now. Mobile printers, particularly Zebra printers, is what we do, and those you can mobilely print to at the moment. So a list of all of the printers and devices that we currently have available is here now. Additionally, off of the iPhone app, you can also communicate with beacons and beacon technology, which is a big thing, so various types of beacons. So I would encourage everybody to go and take a run through our supported devices page, and as well as the iPhone app. And if you have any questions, or if there's great need for additional devices to be supported, we're more than happy, and we want feedback on that too, and what devices everybody would like to see.
All right, sounds good. All right, we're gonna head over to Adam, and he's gonna talk a little bit about the GeoVent processor. So, Adam.
Great, thank you, Trevor. So my name's Adam Wonkoff. I'm the product lead of a product at Esri called GeoVent Processor. And can you guys see my video okay? Can you see that, Trevor?
Yeah, we can see you. We're not seeing your talk yet.
Perfect. Okay.
Good to go.
So ESRI is focused on geospatial reasoning. In this, in legacy terms, is considered GIS, or Geographic Information Systems. And we see a real opportunity for applying geospatial to the Internet of Things as geospatial is really inherent in just about everything that's on the Internet of Things. So we see the Internet of Things as something that ties together the physical, digital, and analytic worlds. And lots of our users and customers go out in the field and try to collect information about the world. And they try to digitize that in and record that into a database that they can then use to inventory what's out in the real world. Most recently, we're seeing that by the time they actually do that, it's out of date. So the Internet of Things is really an opportunity for these customers and other folks to not only digitize the world, but get a real-time instrumentation of what's going on in the world. And so what we're focused on is how do we apply analytics to that data, not just putting this information on a map and seeing it and visualizing it, but how do we actually perform analytics in a geospatial fashion on that data as it's received, as it's streaming in. So one question we'd like to pose is, kind of what would your things do if they knew about their changing environment? And that changing environment could be other things coming closer, it could be weather or other types of incidents coming in, or it could really be any kind of geospatial activity. So we think geospatial reasoning is needed amongst the Internet of Things, and connected environments, connected buildings, vehicles, if it's HVAC systems on a building, or black boxes in a vehicle like Sierra Wireless or other types of devices out there. We really see this as kind of coming together, and how do we actually analyze this data across all these different domains? And when we detect a pattern of interest, how do we notify personnel, or how do we even notify potentially another thing? So this, we kind of see this as an opportunity to increase the sensing technology of these things that are out in the space. So we're going to focus on connected environment for the opportunity of discussion we have today, and the nature to machine interface. So just a few examples, there's lots of these out there. There's live feeds of earthquakes and wind measurements, as well as flood gauges and water systems. But what we're going to focus on today is kind of weather, and how can we use weather on the Internet of Things to make our things more contextually aware of what's going on. So if we're getting bad ratings out of a device, can it be because there's bad weather or other types of incidents here? Or maybe the thing needs to change its behavior based on weather conditions or other factors that may occur. So USGS is here in the United States, that's our geologic survey, and they basically have real-time instrumentation of stream gauges across the nation. And we also have another organization called NOAA, which is responsible for all of the weather conditions and water conditions and all of the coastal area around the United States. And both of these organizations make data available for free for the general population to consume and work with. So this can include watches and warnings. So this is what we're going to show in a demonstration in a minute, is how can we use these watches and warnings to inform our things and do something based on that event occurring. GeoRSS is the kind of de facto standard for how these organizations share this data. So you can subscribe to an RSS feed, but it's a special type of RSS feed that's geo-enabled. So it has location on it, and it has additional context of what's happening in space on those events. So going more down into a micro level, so that was kind of macro, big nation kind of weather and warnings and things. But going down to a micro level, there's lots of sensors out in the world today that we can leverage to get more detailed and analytics about what's going on. So just as the Lebellian folks presented earlier, there's these sensors that are out there in these vineyards. So this is a picture of one of our partners, Valarm, who's deployed these devices out in vineyards to better gauge activity at the vineyard and how they can adjust their behavior and their farming and the other mechanisms they do there. So there's a few devices here, and these are becoming much smaller, where we have micro weather stations that can report temperature, humidity, pressure, and other types of atmospheric conditions, as well as air quality, so CO2, carbon dioxide in the air. So if you had a shelter and you had CO2 sensors deployed inside, you may want to detect overcrowding situations by lots of people coming in together, and we could detect significant CO2 levels and warn people about that situation. Or even light sensors or chemical sensors. So if we detect some type of fume in the air, we may want to alert other things in the area or alert somebody to take action accordingly. So I have a sensor board here that's got these devices on them. And what we can see here is that these are all connected through a commodity Android device. And this is commodity hardware that we're connecting through USB to this device. And this device is going to report all of the information about these sensors to a server so that we can analyze this data as it streams in. So we've got the weather, the air conditions, the lights, and the chemical sensors. So let's take a quick break here to do a demo. And I'm going to open up a dashboard here. And what I can see is I've got a number of gauges on the left here. I can see the CO2 quality here, the volatile
Adam,
organic. Yes?
Sorry to interrupt. Oh, there your demo showed up again. Sorry, I was just making sure people could see it.
Okay. So we can see the gauges on the left there. So I've got this board and I'm going to interact with it. So I'm now placing my hand over the light sensor here, and we can see that there's a light level on the bottom and the middle there. And we should see that light level go down. We can see that that blue bar just depressed completely. And if I take my hand off the sensor, I can see that in near real time showing back up on the display here. So hopefully there's not too much latency on the network here. I can also interact with other sensors on the board. So there's a CO2 sensor, and I'm going to blow into it so I can simulate CO2 activity. So I just blew into the sensor, and you can see not only on this gauge over here on the top left, but also on the map that my symbology is changing based on the activity. And I can also see that I'm getting a situation report, that there's excessive CO2 levels occurring on this thing, the CO2 sensor. And I actually track how long that's occurring. So we can see that that's been ongoing for the last 16 seconds. And when the dioxide levels go back down to normal, we should see that that incident finishes off. So we can use this geospatial reasoning. I mean, it doesn't have to be geospatial. It could be just real-time data that's coming in. So there's nothing geospatial about this other than we're showing it on the map with symbology relative to other things. So if we had many other CO2 sensors, we could see if there's a pattern because lots of them are detecting this or not. And we can now see that that alert has now been dismissed, and it tracked the duration of that as well. So it kept the state of how long that condition was occurring. So the next thing I want to do is let's bring in some moving entities. So I'm going to zoom out a bit and change the base map to National Geographic. And as soon as our map shows up here, I'm going to simulate some activity, and I've sped this up given the short duration we have here. So that we can see this occur. And what we're going to see is I see a few vehicles moving around in the area. And I see a red shape on the screen. Now that's actually a weather warning coming from NOAA. And I'm listening in real time to receive real-time alert weather warnings about that. And I've got a rule in my geospatial analytics that says if there's a weather warning and it intersects one of my stations, one of these sensor board stations, I want to be alerted about that. And we can see that showing up down below that says that this station is in a severe thunderstorm. So as that condition continues to move, we're doing this analytics in a streaming fashion, and we're alerting these displays as appropriate as quickly as we can. We could also alert through email or through XMPP or maybe through MQTT to another thing that's out in the field. Now we're going to continue to watch this storm as it progresses here. And it's not just detecting when these storms are intersecting with stationary points. We can actually do it with moving points as well. So this ambulance that's moving around there is going to intersect this this thunderstorm, and we should see in a couple seconds that an alert is detected on the server, and we should see, yeah, there we go. It's inside the thunderstorm. So we're detecting not only that this weather is intersecting something, but the thing that it's intersecting is moving as well. And we think that this is a really important kind of capability on the Internet of Things. Now let me flip back over to the presentation here. And the way we do this is very similar to what you guys saw with the Node-RED and the other types of things where you have a graphical interface to wire this logic together. So in conclusion, and one final point, we want to connect everything with the Internet of Things. We think that there's a really good opportunity for spatial to complement the existing analytics that are out in that space. And we think that things will start to emerge so that this actually goes closer to the devices, so we can improve the sensing of the things that are out there and improve the behavior of the things that are out there. So we're looking as an opportunity internal to Esri, as well as working with gateway providers to bring this technology closer to the device on the gateways themselves. So if it's a wide area network, a LAN, a PAN, or a body area network, or whatever the network is, bringing this kind of capability closer to the devices. So I think I've hit my 10-minute mark. So if you'd like to learn anything more about this product or the sensors that we use through this, here's a couple links.
Great, thanks, Adam. Trilopos actually had a question for you from inside the panel, and is wondering if you have any specific query languages that you guys are using or supporting with the system.
So we're not using any kind of standardized query language for this. It's very SQL-like, where you can define, query definitions, when this condition is with operators greater than or equal to. But the thing we kind of add is all the spatial operators. So when this geometry is inside this other set of geometries that are interesting, or it's entered or exited an area, those are the types of things that we're adding on to the query language.
Very cool. All right, now it looks like Ilkim's back from Stockholm, so hello, and I think he's going to be talking about XMPP and business models, so we'll head out that direction.
Myself? Oh, yeah. Do you hear me now?
Yep, we can hear you.
Ah, interesting. And now I should do some share of screen share, yes. And choose a window. Okay, I choose a window. Do you see a presentation?
Yes, it's looking good.
So
on Max, we've been having a.
Don't know if I. Okay, I go for it then. Yeah, thank you. Since I'm having a bit of an internet problem, I see if I get any demo working. But anyway, we are Sustainable Innovation is a small company. We're doing good energy efficiency projects, especially around entrepreneurs, new ideas, and big companies. So we are having a sort of unique cross structure that we're having big companies, which is Sweden-based mostly, but E.ON, for example, the European utility, and Vattenfall is also a big utility. So we try to get the utility being together with a car creator, Toyota, doing things with the building owner in Stockholm. And there we use a lot of entrepreneurs to get new technology into the energy sector. And we have talked a lot with this device explosion, and all these things that's coming up, and the billions and so on. And we talked about all these clouds and all the technology that we now create to get to devices, which is more or less what we had before, although we had a lot of obscure protocols, Modbus, KNX, you name it, Loanworks. I'm in the Loanworks generation. I was in endless meetings with security guys and everything, and Loanworks was the final solution. It had everything. It had physical layers, it had a certified way of telling a wall socket is a wall socket, and it has a relay in it. And it totally gone. Nobody knows what Loanworks is, more or less. And now we're doing the same thing with clouds. You getting data from devices, putting them in the cloud, and perfect things happen in there. But how do you get between them? So what's happening now is that you add services to the devices, which gets you even closer to the clouds. Even if you have Zigbee or Z-Wave or whatever technology on the bottom level that's quite interoperable, you tend to get your devices into a business model. So for me, being able to lock the refrigerator door from the scale is very far away. The app containing the scale information is not able to talk to Electrolux app. And this is getting very complex for me in doing energy efficiency services, because I end up with all this API complexity. They're slightly different. Most of them use JSON. Yes, they have OAuth, or they have a device model that is slightly different from the other ones. So if I'm a utility and need to integrate 10 different companies' heat pump app technology, I will never start that project. It's too big. So we need to federate those different, because what we end up is those silos, and me as a person having these endless apps that don't talk to each other. And the solution for us was then to go for XMPP and the chat technology. The basis for it was that we couldn't put a hub in the middle. We cannot use if then that as a solution for the business model to create their own businesses. So an energy service company is very reluctant to put everything into another integrator, another level of integration. And so we're down to, we need something that's nobody is in the middle. So what technologies do we have? We had Corba. That was a common object request broker thing. We had SOAP, is dying. And we then get JSON for the one of the solutions. And for us then, well, mail, that's working. It's getting data between any company to any person in that company. So what about chat? Chat is getting any person to talk to any other person in any other company, regardless of the domain borders. The defined protocol between servers in XMPP is a perfect way of transport data. And with the extensible part of XMPP being that we can do so much more than sending chat messages, we have now done extensions to XMPP for sending meter data, IoT data. So that's a defined way, defined language of how to send the temperature, and to give the receiver the information he needs that it is a temperature. It has Celsius. You need to convert if you need it to Fahrenheit. So in our world of energy efficiency, we're now able to model a whole system of alarm companies where they have totally closed systems. I can model them as being a person in another company that I can be friend to. So my smoke detector can easily be friend to my heat pump. And suddenly the two IT department of my heat pump company and the alarm company just needs to open a server-to-server socket and exchange certificates to saying we have a business agreement that this will work. So therefore the business model needs to be there. And just short, SMTP is the same construction, although any SMTP server must talk to any other SMTP server to send the emails. XMPP network is the contradictory to that. A server won't talk to any server unless both of them federate each other. And a client will never talk to another client unless they are friends. So that's the basis we use. And as you know, there's generic servers, there's generic clients. So you can implement this in any languages you like. So by doing this, we actually create a way of getting between these siloed cloud-based services in a very interoperable way, since data looks the same regardless of where it comes from. And it's high speed, although it's a lot of extra traffic for XML, but there's also a V3C standard called EXI, which is creating a very high compression of the XML packages. When you know the schemas, which is very well defined in XMPP, you will get very high compression through the V3C schema of EXI, which is very interesting even for small devices. They can then create binary XML data. And regarding the standardization, we are now having done 10 different, but the main 3, I would say, is the sensor data, which is, you see the 323, which is reading data, and then the 325, which is a control. So by doing that, you will be having read and write. So if you're a friend to a device, and for example, you are a friend to my alarm, would you be able to read my status? So going in for authorization, telling, well, you're my friend, but you won't be able to read my temperature. How do you do that cross domains from different clients? And the only way we found out, tried, is to be having a best friend. So when a device is asked for values, it will ask the best friend to provide information of what to do, if it's okay to give this to this other person. So then we have a provisioning way of telling devices who to authorize for any data. And we can do that cross-domain in very lot of companies together. Totally distributed. Anybody could start any island if they want to, or join the other ones. And for example, it's fairly simple. The 323 sensor data read would just do it able to do several response request response calls, but it could also be very leveraged to do one EQ with the message with the data back. So it can be both large and small. So if I were to ask a friend of mine, could you give me all your metadata? And that friend happened to be an AMR utility, which would give me back 10,000 values. It would take a while. So therefore you need a few steps, that it's accepted, and then it's started, and the data comes, and then it's done. So you can perform a readout of a huge amount of data with this little extension of XMPP. And for you just pass through the actual XML, it's fairly simple. You have types, you have IQ messages, more for the one that would like to look into a bit further. And the control, more or less the same. It's very easy to set a Boolean value to true. And we have that best friend. So I'll try now to pop in to see if there's any questions on that now. No? I could go in to look here to have you connected to a machine. This is a paper mill in Sweden where we have acted a Raspberry inside the mill with the 3G modem, so it could extract data directly from sensors locally. So I will go in and use the ordinary chat window to ask for values. So it would bring me a direct readout from the actual process. So that could be used in a chat view to get me towards an ordinary chat client to get data out from systems. But then you need to have a good language in the chat, being French or whatever. It's a bit tricky. Perhaps you shouldn't use question mark. You could use other things. And that's where this extensions comes in. So when I'm instead using the extensions, I see that it's lost the connection to that one over there. He really wants to call me. Well, I'm not able to read the values from that one. The demo house over here, it's a house in my office. So I should have been able to connect to that one. But instead I could go in to look in my alarm at my house. It's armed home, so my girlfriend has just now added the scale security, so she's probably gone to sleep. And I could read the temperature humidities in the alarm sensors. And these are just values in the same way as I go into a heat pump to read out values from a heat pump. My XMPP client in the JavaScript you're seeing don't do any differences between asking for values from these two devices. And it's a totally distributed process. And I can actually see if this even doesn't have any history data on it. I can see if this one has any history on it. Sorry for the Swedish. Yeah, so in this case, there is two personalities of a device. There's two logins with the heat pump. One is the actual heat pump, and the other login is from the server side. So when I ask the heat pump for values, I can ask, do you have history? And then the other instance of the heat pump would ask, yes, I have history, and that would be the database. So that's more or less what I'm able to show you here at the moment, since that house didn't really want to talk to me. Well, thank you. And any questions on that?
Well, thanks for staying up so late already for us. I think it seems to be an interesting thread through actually this whole panel. I think maybe just open it up to everyone, and if there's any questions within the panel, just I don't know. It seems like there's some crossover between the Compose and the Esri event stuff as well. So.
Yes, it's very exciting, the thing that's happening, and all the data that's coming up in all these different technologies. And as you said, when you're doing alert response, having control over a storm passing by with sensor data, it's fascinating what we could actually create when this data is accessible. The trouble is to get it there.
Yeah.
Being in either of all these systems, how do you get it in between them? And one way, of course, is to define the final language. or the final API, and perhaps that's what Google is doing with buying Nest. Perhaps they soon will have the final API available on their servers, where everybody will put in all their devices and all the data could flow nice and easy between them. And I could in Google say who's to access what field in my devices. But I don't think that would be a good thing.
Adam or Charlampos, do you want to chime in here on some of these?
Joachim, I have a question for you. Basically, we are doing something similar in Compose, so we are very actively trying to add and promote the uses of XMPP for device communication. But since we are also dealing with applications, web applications or smartphone applications, we still stick to RESTful APIs. So my question was, I sort of noticed that we are using XML inside XMPP to describe actions or interactions between devices. So my question is, how would you map a RESTful interface to communicate with the web application or the smartphone application using XMPP as a transport protocol?
Well, in this client, it's a JavaScript client. I can run it on the phone as well. I having an XMPP XML session, there is a package that is doing the XML on the server side and doing JSON locally as well. So it's changing the XML to be JSON inside the client to more easily use for the developers. But this JavaScript client is an endpoint of the XMPP server, so it has having a secure tunnel back to the server. It's called Bosch, and the package I used is Strophe JavaScript. So any client, there are also native Android and native iOS XMPP clients, which would just need to add the knowledge of the XMPP packages for. Do you see my screen?
Yes.
If you go on the XMPP side and go for the extensions, they're all listed here, and being experimental, they are not in a draft state yet. You have those Internet of Things extensions available. So if a client then actually can see the namespace of those schemas that we use for sensor data, any client could learn to get the values out in an interoperable way, because it's defined how to do it in both ends. So that's what we're doing with the alarm company, for example. They're having a total internal structure of how they name, how they do all their devices and everything. But on the API, they have exposed a way they think the devices should look like and their device IDs and so on. And we changed them to be Jabber IDs. So each Jabber ID we could model either to have your home as one, having a lot of fields, not knowing anything about what's actually inside the house, or you can model it to say, well, yeah, in this house you have 10 things that you can talk to. Each have separate IDs, which have fields in them. So you could model both ways. And there's even a concentrator view that you could ask for the graph of devices. But the actual readout of a data point would be exactly the same, regardless of any system. Did that answer the question?
Adam, you want to chime in at all on this, or?
Yeah, I just agree. It's interesting to see the thread throughout all these presentations for real time and interaction and behavior adjustment. And it's just exciting times, Sue. I'm looking forward to learning more from what I just learned in this session as well, Sue.
Yeah, it's great to start seeing some of these crossover projects, and I think it's really exciting to see. As up to this point, we haven't seen a ton of that, so hopefully this will start some new conversations. But it looks like we're kind of hitting our little over our hour time limit, so I just want to say thank you to everyone for taking the time. And if you want, we'll put links up to your slides shows on the site so people can come dig in a little deeper. But just want to say thank you and appreciate you taking the time.
Thank you.
Thank you.
Good rest
Thank
of
you
your day.
very much.
Happy IoT Day, everybody.
Happy IoT Day.